Hi Year 9, I'm going to go through page 17 of the number pack. I've only just realised now that I'm doing the answers that I didn't actually write a question in this first one, so I gave myself a reminder of something to do and then never actually got around to doing it, so that was good. I'll have to change that for next time. Question 2 though, without using a calculator, find the values of the following. So this is just testing your knowledge of square numbers and cube numbers and what powers mean. So I'll just do a few of these and then pause the video, fill in the rest, and you can copy down the answers when they're on screen if you haven't got them already. So 10 squared means 10 times 10, but it wants the value, so the answer of that would be 100. 3 to the power of 3, or 3 cubed, means 3 times 3 times 3, and the answer to that would be 27. So most of these are ones you should know, or they should be powers of low numbers that you should be able to figure out quite easily. So 2 to the power of 6, not one that we're expected to know, but easy enough to figure out. We know it's 2 times 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Okay, so I'll pause the video now and you can have a go at the rest. Okay, there's the answers to question 2. Scroll down and have a look at question 3. Evaluate the following. Now the word evaluate means exactly the same as find the values did in the previous question. It means actually figure out the answer. So again, we should know most of these very similar to question 1, just with a different worded question, that's all. So I'll pause the video here and fill in the answers. There we are. And you can mark your own work. Question 4. Find the value of the following. So again, find the value, find the actual answer. So this bit we've got to do in stages. So 8 squared is 64, 3 cubed is 27, and when we take those away, I learned a neat trick about subtraction recently, that if you increase the one you're subtracting to a nicer number like 30, as long as we do the same to the other number, it makes it a lot easier. So this is the same as doing 67 minus 30, because I've added 3 to both numbers, and that gives us 37. I thought that was quite a nice method. 2 cubed would be 8, times 3 squared is 9, that would give us 72. 7 squared is 49, minus the brackets, which would be 24. Again, show you that method here. That would be the same as if I add 6 to both these numbers. That would be 55 minus 30, which is 25. Part D, 6 squared is 36. I would divide that by 4 first, thinking about bin mass. That would give me 9. Adding 7 to that gives me 16. On part E, I want to do each part of this numerator and denominator separately. So 4 cubed would be 64 minus the brackets, which would give me 36. And on the denominator, 43 times 2 would give me 86. And 9 squared would give me 81. So that denominator would be 5. So this is going to give me 28. No, ignore me. It's not. The brackets will give me 36. When I add those together, I'm going to get 100. I'll come to that bit in a minute. 43 times 2 would give me 86. And 9 squared is 81. So this is going to give me 100 divided by 5, which will be 20. And the last one, 6 squared is 36. Divided by 3 would give me 12. Plus 4 would give me 16. And on the denominator, the square root of 16 is 4. 16 divided by 4 is 4. Number 5, write these lists of powers in order from smallest to largest without a calculator. So it's just another way to test our knowledge of powers. So 27 would be that one, 64, 16, 25. Okay, I'm not going to go through all of these. The only one I'll have a look at in a bit more depth is this last one. And powers of 0, you may know this already, may not. But if you try any power of 0 on your calculator, you'll find that it gives you the answer 1. So actually all of these are equal to 1. So there is no correct order. There's no incorrect order really. They are all equal. Okay. So I'll just pause that now and you can fill in the rest. Pause the video and mark your work. The last question on the page is about understanding powers of 0 and negative powers. Now, until now, we've thought of powers as the number of times that number is being times by itself. So 2 to the power 4 is 2 times 2 times 2 times 2. 2 cubed is 2 times 2 times 2, and so on. Okay, but what happens as we go down this list is that we stop being able to write out 2's. We can't write 0 2's, and we certainly can't write -1 2's or -2 2's, and so on. So we stop being able to represent powers in this way. But what doesn't change is the pattern that powers cause. So if we look at the pattern instead of the number of 2's times together, what are we doing as we go down this list? Well, we have halved that number, we've divided by 2. And here we've divided by 2 again and again. And that makes sense if you think about it. We're losing one of these 2's each time. And if we continue that pattern, what's 2 divided by 2? That would give us 1. What's 1 divided by 2? Well, if I just use a fraction, that would be a half. If I divide by 2 again, that would be a quarter. Keep going. That would be 1/8.
But I got my shoes on.
Divide by 2 again, that would be 1/16.
My shoes, my pop.
Now look at what you notice about those numbers. Look at the denominator of those fractions. Here we've got 2, and 2 to the power of 1 was 2. On 2 to the power of -2, the denominator is 4, and in 2 squared it was 4. 2 to the power of -3, the denominator was 8. 2 to the power of 3 was 8. 2 to the power of -4, the denominator is 16. 2 to the power of +4, the answer was just 16. So we're getting the same numbers, they're just on the bottom of a fraction with a 1 on the top. And this is called the reciprocal. 1/2 is the reciprocal of 2. 1/4 is the reciprocal of 4. 1/8 is the reciprocal of 8, and so on. To go in a bit more depth about the reciprocal, it's what you would times a number by to make 1. So 8 would need to be multiplied by 1/8 to make 1. Okay, let's have a look at the powers of 3 and see if they do the same thing. So 3 to the power of 4 would be 3 times 3 times 3 times 3, and that would be, oh, should have figured this out first, shouldn't I? 3 cubed is 27, 81. Fill in these numbers. 3 cubed is 27, 3 squared is 9, 3 to the power of 1 is 3. Now, let's have a look at the pattern. So, as we go down this list, we are dividing by 3. And we're not going to write out the powers of 3 as 3's times in together, because I know it'll only get me so far. Now, what do we get when we do 3 divided by 3? We get 1. That's odd. We got 1 over here as well. Something interesting there, maybe. If we divide 1 by 3, we could put 1 over 3, or 1/3. Definitely easier to write that one as a fraction rather than a decimal, because that would be a recurring decimal. Divide by 3 again, and 1/3 becomes 1/9. Divide by 3 again, and 1/9 becomes 1/27. And divide by 3 again, and we would get 1 over 81. Okay, so yet again, we're seeing the same numbers as the positive powers, just on the bottom of a fraction. So again, these negative powers are caused the reciprocal. Okay, we'll come into that in a bit more depth in a minute. And finally, let's have a look at the powers of powers of 10. So 10 to the power of 4 is 4 tens times in together. 10 times 10 is 100. So that would be that one. 10 cubed is 1,000. 10 to the power of 4 is 10,000. 10 to the power of 1 is just 10. And as we go down this list, we are dividing by 10. So we're always dividing by whatever number is the base of our powers here. So here we're dividing by 10 again. Divide by 10. Divide this one by 10. And what are we going to get? We're going to get 1. Okay, so starting to learn something here, that anything to the power of 0 is 1. So I'll just write that down here. Anything to the power of 0 is 1. Really key point, that one. Or if you're from Yorkshire, out to the power of naught is 1. Divide by 10 again, we get 1/10. And you can see what's going to happen here. Divide by 10, we're going to get 100th, 1,000th, and 1 over 10,000. Okay, so it doesn't matter what the number is. I now know something about negative powers as well. Anything to the power of negative something is 1 over the power of what it would have been if it was just a positive power. Okay, so 2 key things came out of that pattern. So, for example, if I had the question 6 to the power of negative 2, well, I know it's going to be 1 over because the negative causes that, the reciprocal, and 6 squared is 36.